Good morning. Today we're going to be looking at circles and triangles within circles. So the first thing we're going to look at is isosceles triangles. They're created when we have a chord, like this blue one here, which runs from one point in the circumference to another point in the circumference, and then we can join the centre to one end of the chord, and that gives us a radius. And then we can also join the centre to the other end of the chord. That'll be another radius, because any line from the centre to the circumference is a radius. Now that we have a triangle that has two sides that are the same length, because they're both the length of the radius, then we have an isosceles triangle, which also tells us that the angles in the base here, which I'm going to call x, are both the same, because the angles in the base of an isosceles triangle are both equal. Okay, we can use that when we're asked questions to help solve them. So a question like this one, where triangle OAB is an isosceles triangle, we know that because O is the centre of the circle, A is on the circumference, which means that this first blue line is a radius, and O is the centre of the circle, and B is on the circumference, so the second blue line is also a radius. That tells us that these base angles are both going to be the same. So if we have to fill out all of the angles in this triangle, the angle at the top here is 80 degrees. We know that the angles in a triangle are up to 180. So 180 subtract 80 leaves us with 100 degrees, which we have to split equally between these two base angles. So 100 divided by 2 means each of those base angles are going to be 50 degrees. Okay. Sometimes you'll get a triangle that looks different and maybe orientated differently. So the ones previously, it was nice and it was pointing up the way. In this case, we actually have exactly the same situation, it's just orientated differently. So the blue line from O to B is still a radius. The blue line from O to A is still a radius. So we still have an isosceles triangle, and the triangle OBA or OAB, whichever way around you prefer to go. And that tells us that if we're going to work out all the angles in this triangle, the two base ones, so the angle OAB and the angle OBA, are both going to be the same. So if we know one is 25 degrees, then we also know the other one is 25 degrees. So to work out the angle at O, the top of the triangle, or bottom in this case because of the way it's orientated, we're going to have to subtract from our total of 180 degrees, we're going to subtract our two 25s. So we're going to subtract 50 degrees, because 25 and 25 is 50. This leaves us 130 degrees. So this angle at O is 130 degrees. Okay. You can use these tools then to solve lots of other questions. Thank you.